Hello, mic check. Hello guys. I think I am online, right? Where's the pen? Hello. Anybody here? Okay, I think where's the pen? Okay, I found my pen. Okay, so in this session, I hope we are live, right? Okay, yes, we are live. Okay, so in this session, we are going to discuss about 50 problems. Okay, this is going to be the part 1 of the problems. Okay, and then there will be part 2. Earlier, I have done one shot for some basic concepts of chemistry. So I have revised all of the concepts. Okay, in that video. Got it? Just wait for a second. Okay. So every time we come online at this particular time, okay, somebody has joined, write your name. Whoever has joined, you write your name. Okay, let me see who is in the session. Okay, and for this whole session, try to answer questions. Okay, if you are watching a recording, okay, try to pause the video if you need more time. Okay, otherwise I will give you 1 minute of time for every question. Okay, if you need more time when you're watching the recording, you can actually start. Okay, you can just pause the video and start doing the problems. Make sure to be honest, and out of 25, okay, try to calculate your marks. Okay, we are going to do 25 questions and then you have to calculate your marks. Okay, be honest with yourself, and at the end of this session, if you are watching the recording, comment your number of marks, and if you are watching it live, okay, try to comment, try to just write in the live replay how many marks you got at the end of the session. Okay, so we are going to start. Just put down your name, guys. Just put down your name. We can start now. Okay. So some basic concepts of chemistry. Let's start with the very first problem for the day. Okay. Now the first problem of the day is number of atoms in 4.25 gram of ammonia is approximately how much. So you need to calculate how many number of atoms are there in this gram of ammonia is approximately how much. So I am starting a time of 1 minute. I am going to do this for every session, and hence you will do the question, and if you are able to solve it in 1 minute and get the correct answer, you mark +4 for yourself. Okay, if you got the correct wrong answer, take it -1, and if you didn't do the question, put it 0. Okay, at the end of the session you tell me how much marks you got. Okay, or you can tell me how much question you did. So let's start with the first question. Number of atoms in 4.25 gram of ammonia is approximately. Let's start. Okay, tell me. Number of atoms in 4.25 gram of ammonia is approximately how much? .25 gram of ammonia. Guys, put up your name. Whoever is watching the session, put up your name, guys. Okay, done. Now we can start. Okay, Jyoti is saying, sir, question number 1, option 4 is the right answer. Okay, let's see, Jyoti, if your answer is right or not. Okay, let's start. So first of all, see, the question is very easy. Okay, we are going to start from very easy problems and then we are going to move with the tough ones. Okay, so let's start. So number of atoms in 4.25 gram of ammonia is approximately how much? So first of all, there are 3 ways to find number of moles: weight, volume, and then what? Number of particles. Okay, so now 4.25 gram. So what is the what is the molecular weight of ammonia? Sir, molecular weight of nitrogen is 14, and for sir hydrogen it is 3. So 14 plus 3 is how much? 14, 15, 16, 17. So it's totally 17. Okay. So 17 gram is the molecular weight. Okay. So what is the number of moles? What is the formula for number of moles? So the formula for number of moles is given mass upon molar mass. Given mass upon molar mass. Okay. Now let's start. Okay, I'll just do this. Okay. So given mass is 4.25 and molar mass is what? Molar mass is 17, right? Because it's ammonia. Nitrogen is 14, ammonia 3, 14, 15, 16, 17. So 4.25 by 17. Okay, this is the value of number of moles. Okay. So if you want to convert number of moles into what? Into number of particles. What do? You multiply with Na. I hope you have heard this right. And if you do not know the concept, go watch my video on one shot of some basic concepts of chemistry. Okay. So if you multiply this number, okay, the answer you will get is 4th. Got it? And yes, Priya Jyoti, your answer is right. The answer is 6 into 10 to the power 23. I hope now you can understand. What is the value of Na, by the way? Na is 6.023 into 10 to the power 23. Got it? This is the value of Na. If you put it, you will get the number of particles. This is number of moles into Na, you will get number of particles. Understandable? Let's go to the next problem. Okay. Oh, I need to cancel this so that the cursor can work. Okay, so next problem is, which of the following contains maximum number of atoms? Which of the following contains maximum number of atoms? Guys, start doing this question. Try to calculate your marks. Okay. Yeah. Which of the following contains maximum number of atoms? Tell me. Priya Jyoti, whoever is available. Question number 2, 1 minute is their time. If you are watching recording and you need more time, just pause it. Okay. But try to calculate your time, the marks at the end of the session. Okay. Which of the following contains maximum number of atoms? Okay. 4 gram of hydrogen, 16 gram of O2, 28 gram of N2, 18 gram of water. Tell me. 20 seconds are left. Try to answer. Okay, 7 seconds, 6 seconds. Now I can see there is 30-second gap. Okay. The question is very easy. The number of particles depend upon the number of moles. Okay. More will be the number of moles, more the number of particles. Got it? So it's very easy. Let's start doing it. So first of all, number of mole is equal to given mass upon molar mass. So given mass upon molar mass of hydrogen is 2. Answer 2. Given mass 16. What is the molar mass of oxygen? 32. Answer is 0.5. Okay. Given mass is 28. Molar mass is again 28. Molar mass is N28, right? Now, given mass is 18. Molar mass of water is 16, 17, 18. So 18. 1.5 is 2. So this is the max number of moles, highest number of moles. So highest number of particles will be in the 4 gram of hydrogen. Okay. Let's see if somebody has answered. Okay. Kanishka, you have answered question 2, option number 1, and you are right. Good. Oh, sorry, Priya Jyoti. Now let's go on to the next question. Okay. Okay. So next question is 5.6 liter of oxygen at STP contains how much? See, this is at STP 5.6 liter. Okay. Try to find out. Priya Jyoti. Okay. 27, 30 seconds more. Try to do it quickly. 5.6 liter of oxygen at STP contains how much? I'll just put the session has started. Okay. Okay, now let's start doing this problem. Let me just send a message. Okay. Good. Okay, so 5.6 liter of oxygen at STP contains how much? So first of all, we need to find number of particles. Okay, we have to first convert this amount of volume into moles and then multiply the moles with Na to get number of particles. That's it. Okay. So can you tell me how much volume, okay, is occupied by 1 mole of a gas? Somebody has answered question number 3, option number 2. Let's see. Brush. Okay, yeah, brush. 5.6. So first of all, given volume upon molar volume. What is molar volume? Volume occupied by 1 mole of gas. So that is 22.4 liter. Okay, and this is 5.6. If you cancel this out, what is the value? Okay, if you cancel this out, it is somewhat 1 by 4. Okay, and this is the number of moles. 1 by 4 is the number of moles. You have to multiply it with Na. So once you multiply it with Na, what do you get? Na by 4. So Na by 4 is how much? 6 by 4. 6 by 4 is somewhere around 3 by 2, which is somewhere around 1.5. So 1.5 10 to the power 23. Okay, so it's, I think, this number. Is this option number 3? Priya Jyoti, third, option number 2. Are you doing something wrong? 5.6 liter of oxygen at STP contains it's talking about atoms, it's not talking about molecules. See, this is Na by 4 is the number of what? Number of molecules of oxygen, and 1 molecule of oxygen contains 2 atoms. So it is asking about atoms. So atoms, it means for 1 Na4 molecule, 2 times of the atoms will be present. Okay, got it? 4, right? Once you cancel it out, Na by 2. So once you cancel out Na by 2, what do you get? Na by 2 is around 3 something. Okay, so 3 into 10 to the power 23 something. So this is the right option. So 2 people have answered. Nandini, Priya and Priya Jyoti. Both of you are right. Okay, so you can get yourself 4 marks. Write down 4 marks in your notebooks. Okay, let's start with another question. So here is the next question in front of you. Sum of number of protons. If there is any problem that you can't see the question, you let me know down in this comment section. Okay, so let's start. Question number 4. Sum of number of protons, electrons and neutrons in this much gram of 12 carbon is how much? So it is asking us the number of protons, electrons and neutrons. Okay, first of all, find the number of proton, electron and neutron in one carbon atom. Then multiply with the number of particles and you can get the answer. Let's see who's going to do this. Question number 4, guys. Sum of number of protons, electrons and neutrons in 12 gram of 12C6 carbon is how much? 6 is 18, and 18 you need to multiply for 1 carbon, you need to multiply by 18. Tell me. Okay, sum of number of protons, electrons and neutrons in 12 gram of 12C6. Okay, let's see if somebody has answered. Somebody said 5.6, 2 into 14 into Na. 2 into 14 into Na. Why 14? Number of protons, electrons and neutrons. See, what is the total amount of electrons, protons and neutrons? Tell me. 12C6. So 12C6 is like 6. Fourth, option number 3. Fourth option, somebody has found the answer. Fourth, option number 3. Very good. Okay. Somebody else, Priya Jyoti. I'm not able to understand like what you are writing. 5.6 divided by 2.4. Okay. 6.02 into 10 to the power minus 23 divided by 2 is this much. Oh, you are telling the previous problem, right? Yes. You are telling the previous problem. But can you tell the answer of this fourth question? Tell me the answer of this fourth question. Let's start answering. Okay. So brush. Yeah. Sum of number of protons, electrons and neutrons in this much gram of this carbon atom. Okay, so from the carbon atom 12 C6, it means 6 are how much? 6 are protons. Okay, obviously 12 minus 6 is the number of neutrons. Okay, and this, if this is balanced, then the number of protons will be how much? It will be electrons will be 6. So 6 6 6 proton, neutron, electron. Okay, so what is the total number of protons, electrons and neutrons in one carbon atom? That is 18, right? 6 proton, 6 neutron and 6 electron. That for question number 3. Yes, very good. Okay, Nandini, Priya, for option number 4 and 3, you are right, don't worry. Okay, now you have 18, right? 18 is the number of particles for one thing. Okay, we have this one particle containing 18. Got it? Now we have to find out what is the total number of particles contained by 12 gram. Okay, so 12 gram is what? See, you have to find moles is equal to 12 gram. Got it? Given mass. Somebody has answered. Okay, so given mass upon molar mass is 12, given mass is 12 again, right? Then you have to cancel this thing out. Okay, so this is 1, wait, and 1 into 18 is 1.084, wait, are we getting something wrong? Think about this. 10 to the power 23, wait, I think there's something wrong with the problem. Wait, I think 12 gram, okay. Am I doing something wrong? Let me know down in the comment section if I am doing something wrong. Wait, 12, 18, good. So we have one number of mole. Yes, we are right with one number of mole. One mole contains any number of carbon particles. Good. Okay, and every carbon particle is containing 18 elements of proton, electron and neutron, and this should be the answer. So for the value of Na is 6.023 into 10 to the power 23 into 18. So if I multiply 18 with 6, how much do I get? What is the value we get after I multiply 18 into 6? So 18 into 6 is how much? Somewhere 108. You can write it at, instead of writing 108, write 1.08 and in 2 zeros, add 2 zeros over here. Oh, you are doing right. We are not doing some any answer. Okay. So 1.08 10 to the power 23, 1.08 10 to the power 25. Okay, sorry, 25 is the power because 2 zeros got added from 108. Okay, so this is the answer, option number 3. I hope you guys understood, right? 18 into Avogadro number. Yes, it's right. Okay, I was just a little bit confused. Okay, now do this problem. Which of the following has the highest mass? 1 gram of atom of carbon, half mole of CH4, 10 mole of water. Okay, good. 3.01 10 to the power 23 atoms of oxygen. It's very easy question, you guys can do it. Question number 5, guys. Nandini, Priya and Priya Jyoti. Okay, 2 guys with just same names. Okay, 1.084. Okay, yes, that is the answer. Priya Jyoti, try to do this question quickly. There is a 50-second gap right now. Okay, now I think we are done. Okay, so which of the following has the highest mass? We have to calculate which is the highest mass. What is the mass of 1 gram atom of carbon? 1 gram atom. Okay, it's not simple 1 atom. I am talking about 1 gram atom. So 1 gram atom of the mass is, it means 1 mole of carbon is having 12 gram of mass. Okay, it's not 1 gram of carbon. No, it's 1 gram atom of carbon. Don't get confused. Now, half mole of this methane. What is the mass of methane? Sir, carbon is 12 and this is 4. So 12 plus 4 is 16. Half mole will be, 1 mole is 16, half mole is 8 gram. Right? Now, let's see if somebody has answered. Somebody has answered 5. Option number 1, Priya Jyoti, you are right. Okay, 10 milliliter of water. Do you know, for 1 mole there should be 22.4 liter. It means 22,400 milliliter. And if you put 10 milliliter, this is the amount of moles that you have of the water. And you have to multiply it by 18 to get the amount of mass. And it's a very small number we can already see. Okay, we want what? The highest mass. Remember this thing. Now, 3.011 into 10 to the power 23 atoms of oxygen. So, how much? Okay, 3.01, it's like half of 6.023. It means it is Na by 2 atoms. Na by 2 atoms, it means half of the 1 mole. Because it is half of Na, it means half of 1 mole of oxygen. Okay, atoms of oxygen. See, okay, these are like atoms. Okay, so 1 mole, half of 1 mole. So, 1 mole will be 16. Okay, and half of it will be 8. Got it? 8 gram, 8 gram, 12 gram. So, option number 1 is the right answer. Got it? I hope everybody understood, right? For real 10 milliliter of water, 10 grams. Very good. Okay. Let's go on to the next question. Okay, this is the next question, guys. Which of the following contains the least number of molecules? It's very easy. Try to do the problem. Again, same type of problem. Question number 6. Which of the following contains the least number of molecules? Least number of molecules or the least number of moles? Okay, both of them are going to be the same. Least number of molecules or least number of moles, both are same. Okay, 3 people are right now over here. Try to write your name, guys. Okay, only 10 seconds are left. 4, 3, 2 and 1. Okay, now let's start doing this problem. Which of the following contains the least number of molecules? It means least number of molecules means least number of moles. Okay, so we have to check the least number of moles. Okay, so see, what is given mass upon molar mass, that is the formula for number of moles. Okay, so what is the given mass? Sir, 4.4. What is the molar mass? Sir, 44 gram. Right, so if you cancel it out, it's 0.1 moles. Okay, what about this ammonia? What is the mass of ammonia? Sir, this is 14, 15, 16, 17. Sir, 17 is the molar mass. So number of moles is equal to given mass upon molar mass. So you cancel it by 2 and then divide by 10, that is equal to 1 by 5 and that is 0.2. Okay, now again 1.6 gram of methane. Methane is itself 16 gram. So 1.6 gram is how much? Given mass 1.6, molar mass 16, cancel it out, 0.1. Okay, so we have gone lesser, greater, again lesser. So let's see if this is the answer or not. Okay, see, we can already see this is the answer, because if these are not, if these are equal, obviously there can't be two answers, so they won't be the right option. Okay, and this is already greater, we want the least, so already this is the answer. If you just don't want to say like do this problem and save your time, you can like use this tactic. Okay, so what is the mass of sulfur? Again tell me. 32. And mass of oxygen somewhere around 16 plus 16 again 30 to 32. Okay, so say there will be some bigger number in here somewhere around 64, and if you write 3.2, the ratio is so much lesser as compared to these values. Okay, so as the ratio is so much lesser than these values, hence this is the answer. Okay, so this is the least amount of moles, hence this is the least number of molecules. Got it? I hope this question was understandable. Let's see who has answered this question. Okay, question number 6, fourth option Priya Jyoti. Question number 6, Nandini Priya, you are right. Okay, very good. 5 people are joining. Why you guys are not writing your name? Try to write your name, guys. okay? Try to write your name, okay? And try to answer things, okay? If you are watching this session, it's okay. Try to answer, okay? Don't do a Netflix or binge watch, okay? Because if you want to get marks, you need to do it. And if you don't want to, then you should avoid. Okay, now here is the question in front of us. Let's start the timer. I'll just give a little bit of more time for this question, okay? It's just 20 seconds extra, I guess. Okay, I can start the timer now. Let's see, let's read the question, okay? I can't fit it anywhere, okay? Elements A and B form two compounds, B2A3 and B2A. 0.05 moles of B2A3 is this much weight, 0.10 mole of B2A is 10 gram. Atomic weight of A and B are how much? So it is asking us the atomic weight of both of them, okay? That's why I have given them more time. Two equations will be formed and you need to find two solutions, that's it. Okay, let's see what's the answer. 30, 30, 40, 20. Six 6, okay, no, it is the same problem. Let's see. Question number 7. What's the answer, guys? Form two equations from the given statement and solve them and you will get your answer. Form two equations. Okay. Now, let's start. See, first of all, we have to understand 0.05 moles of B2A3, okay, is 9 gram. It means what is the molecular mass? Tell me. What is the molecular mass of B2A3? Sir, B2, it means two particles of B and one particle of A3, right? Three particles of A is weighing how much? 0.05 moles are weighing 9 grams. Then what is the weight of 1 mole? It is 1 by 20, right? This value is what? It is 1 by 20, right? Is equal to 9 gram, okay? So if I want to find 1 mole, I have to multiply both of the terms by 20, right? Just unitary method, that's it. 90 20 is 180. So this is the mass of B2A3, got it? Same way, 0.1 mole is how much? It is 1 by 10, right? So 1/10 of a mole is weighing 10 gram. Then 1 mole will weigh 100 gram, that's it. So B2A will weigh 100 gram, okay? Now it means if we are adding two particles of A, it is costing 80 extra, right? Two particles of A are added, sorry, minus, when you subtract two particles of A, okay, 80 amount of mass separate. It means two particles of A are weighing around 80, right? So one particle of A will weigh around 40. So A is 40. Okay, I think option number 3, let's see. Okay, no option is there, 30, 30. You can just tick out that answer and don't need to fight. If you are enough confident, only then tick out with one answer. Otherwise, try to find another answer and then confirm and then answer. Okay, otherwise I'll go with the third option. Okay, now 40 and 30. Now what is the option number C? A is 40, A is 40. So 100 minus 40 is how much? Weight of 2 B2, right? That is 100 minus 40. How much? 100 minus weight of A is 60. So 8 B2 will be 30, right? B will be 30. B2 is 60, B will be 30. So 30, 40 and 30, and this is the option third. Let's see who has answered this problem. Okay. So first of all, Nandini has answered 7th, option number 3. Very good, Nandini. Priya Jyoti, you have not answered till now. Is there any problem? Let me know if you are not able to understand this problem. Okay. First, find 1 mole of the value. I found it 180. 1 mole is 100, right? Subtract it. Then you can just solve the equation, like 2 times of B plus 3 times of A is equal to 180, right? Form an equation like this, okay? And 2 times of B plus A is equal to 100, right? You just need to form the equation and then again 2 equations, 2 variables, solve the answer, right? Okay, I hope you have done these types of problem. Now guys, let's go on to the next problem, question number 8 of the day. .4 gram of any unknown gas occupies this much liter of volume. The gas may be, so what is the gas? which gas we are talking about? If we are talking about 4.4 gram of an unknown gas occupies 2.24 liter of volume at STP. Okay, got it. So yeah, let's see which one is the right answer, guys. Tell me. Nandini, Priya, okay, Priya Jyoti, I have not received your answer till now. Are you watching the session or not? 4.4 gram of unknown gas occupies 2.24 liter of volume at STP. The gas may be. What can be the gas? Okay, these questions are simple. I don't want you to take more than 1 minute of the time. These questions are simple. I don't want you to take more than 1 minute of time. Okay, let's start. Hey, why I'm selecting timer again? So 4.4 gram is equal to 2.24 liter, right? If I multiply them both with 10, you get 44 grams is equal to 22.4 liter. Okay, and 22.4 liter is the mass of 1 mole. Sorry, volume of 1 mole. Got it? So it means this is the mass of 1 mole of the gas. Understandable? 4.4 gram is the mass of 2.24 liter. 44 gram is the mass of 22.4 liter, which is the mass of 1 mole. It means this is the mass of 1 mole. So any gas which has a mass of 44 is going to be the answer. But okay, CO2 is the right option. Is third option right? Or there is one option, 1 and 3 both. It means third can be the answer. Can 1 be the answer? Let's check if this has a mass of 44 gram. So N2O, it means 14 into 2 plus 16, right? Into 1. Okay, 14 to 28. Okay, plus 16. So what is the value of 28 plus 16 is 7 to the 14 to 4, 41. This has a mass of 44 also. N2A also has a 44 mass, CO2 also has a 44 mass. It means this is the right option, 1 and 3 both. Got it? And it's very easy. You just utilize what is the volume for 1 mole. Got it? That's it. Now let's go on to the next problem. Let's see if somebody who has answered this problem. Okay, Nandini, Priya, you have answered option number 8, third. Oh, you have answered, okay. Okay, Priya has answered 8, option number 4, and Nandini, you have answered option number 8, 3. You have answered 3 because you know, you thought about 44 gram and then suddenly your mind got onto CO2 is the 44, right? But you didn't see. Okay, this is a tricky question, not a tricky question, I'll say psychological question. It is just trying to trick your psychology, okay? So that's why in a hurry you didn't check the mass of this N2O. That is your mistake, Nandini, Priya, okay? Try to be correct the next time, okay? Again, 9th problem, guys. So timer, let's start. Which contains least number of molecules? Tell me quickly. This is very easy question. Least number of molecules, guys. Question number 9. Least number of molecules, 1 gram, 1 gram, 1 gram. Okay. So given mass upon molar mass. Okay. Tell me, given mass upon molar mass, that will be the ratio. It means given mass is like constant for everything, 1 gram, 1 gram, 1 gram, and molar mass is different. So more the molar mass, lesser number of moles, lesser number of molecules. So which has the highest number of moles is the right option. Let's see if somebody is able to answer this question. Nandini, Priya, Priya Jyoti. Okay, I'll call Priya, Priya, and Nandini, Priya, Nandini. Okay. So we got our first answer from Priya, 9th option number 2. Let's see if 9th option number 2 is right option or not. Okay. Let's see, Priya, if you are right or wrong. Okay. So which contains the least number of molecules? Sir, least number of molecules, sir, given mass upon molar mass, given mass upon molar mass, given mass upon molar mass, given mass upon molar mass. Which one of these numbers is the least? The highest denominator has the least number. Least number of moles, least number of particles, that's what we want. So this is option number 1. And Priya, you are actually wrong for this one. You have written 9th option number 2, you are wrong. Okay, this is not the answer. Option number 1 is the right answer. So Nandini, you are right. Okay, I'll call you Nandini. Okay, so that I don't get confused. Okay, let's go on to the 10th problem of the day. Don't worry, this session is not going to be long. As long as you guys are answering fast, this is going to be quick. Okay, and these are just easy problems. Okay, I feel like you can do it. Okay, so start. Now, if V milliliter of the vapors of substance at NTP, okay, NTP, weight 12 gram, okay, then molecular weight of substance is how much? It is like the previous question which told us 2.24 liter of something weighs 4.4 gram. How did we find out the mass of 1 mole? You need to utilize the same problem. Okay, I'll just wait. I'll like reset it. I'll start it again to get you more 20 seconds. Okay, for this problem. 9 problem number 1. Okay, 10th. Tell me the answer, guys. Try to do it, guys. Okay, try to find out the mass of 1 mole, sorry, the molecular weight of the substance, or maybe just mass of 1 mole. Let's see if somebody has answered or not. Nandini, Priya, Priya Jyoti. Try to answer, guys. Okay, 5, 4, 3, 2 and 1. Done. Okay. See, the logic is very simple. I'll tell you the logic. V milliliter occupied, this is milliliter, okay? Remember, this is milliliter, not liter. Understandable? Now, V milliliter weight 12 grams, okay? Then what is the mass of 1 milliliter? In 1 milliliter will be weighing 12 by V, sorry, W by V, right? Then what is the volume, weight, this is the gram, right? Weight. Then what is the weight, oh sorry, weight of 22,400 milliliter. Why 22,400 milliliter? It is equal to W by V into 22,400, right? Okay, this is going to be the weight of 22,400 milliliter of gas. And what is 22,400 milliliter? It is 22.4 liter, which is actually 1 molar volume. It means it is 1 mole of a gas. So 1 mole is 22.4 liter. 20,400 milliliter, and this is the mass. W by V into 22,400. W by V into 22,400. This is going to be the right option. Got it? Let's see who has answered this problem. So Priya Jyoti, you are the first one to answer this problem. 10th, option number 1. Very good. Okay, let's go on to the next question. Okay. This much molecules are removed from this much milligram of H2SO4. Okay, so it's mg, milligram. Okay, then the number of moles of H2SO4 left are how much? Okay, so we have to first convert both of them into moles and then find out the answer. Okay, you better calculate millimoles. See, this is in milli, this is 10 to the power, not 10 to the power 23, this is 10 to the power 20. So you should calculate in terms of millimoles. So see, everything is 10 to the power minus 3, minus 3, minus 3, oh this minus 2, you can remove this one, okay. So everything is in terms of millimoles, you can find it easily if you calculate it in terms of millimoles. Nandini, are you not able to answer the 10th question? I have not seen your answer for the 10th question. Do it, guys. Okay, let's do it. Should keep it somewhere over here, right? Okay, so question number 11th, right? Let's do it. 3.01 into 10 to the power 20 divided by 6.02 into 10 to the power 23, right? So 10 to the power 20, 10 to the power 23, given number of molecules upon total molecule, okay? Sorry, the value of Na. Now, this is 1 by 2 into 10 power minus 3. Got it? It means 0.5 into 10 to the power minus 3, remove it and call it millimoles. That's it. It means 0.5 millimoles. Okay, what is milli? 10 to the power minus 3. Instead of writing this, I written millimoles. Okay, now 98 milligram. Okay, if you are getting answers in milligram, if you divide it with the, what is the molecular weight of this thing? This is 98, remember this. So 98 milligram divided by 98, you will get 1 millimoles. Okay, 1 millimole. So in this much millimoles, okay, this much millimoles are removed from this much millimoles. Okay, then what is the left? So 0.5 millimoles are removed from 1 millimole. It means 0.5 millimoles will be left. 0.5 millimoles. So this is the option number 2. 11th, option number 2 is the right answer, and let's see who has answered this particular problem. Okay, so 11th, option number 2. Very good, Priya Jyoti, you have answered this problem. Okay, Priya Jyoti, the first one to answer this 11th problem. Now do this question, guys. Vapor density of the gas. I have told you the relationship between vapor density and molecular weight. So where's the mark? I think it should be quick. Vapor density of 11.2, volume occupied 2.4 gram of this gas STP will be how much? $12. Can you explain it once again? Are you talking about 11th problem? See, in case of 11th problem, it's very simple. This is the molecule, this is the weight. Convert both of them into moles. Okay, so you will get moles from this one, some moles from this, which we got as 0.5 millimoles, and from this we got 1 millimoles. So it is saying, if instead of saying this, say 0.5 millimoles are removed from 1 millimole of H2SO4. So if you remove 0.5 millimole, from 1 mole, you will be left with 0.5 millimole. So we have 0.5 and millimoles, it means 10 to the power minus 3. Got it? That's why 2 is the problem. 2 is the right answer. Did you understand this, Nandini, Priya? Did you get what I just said? Convert both of them into moles and then you will get your answer. And now let's proceed with this problem. Vapor density of gas is 11.2. If you find out molecular weight, how do you find out the molecular weight if vapor density is given? If vapor density is given, so the molecular weight is twice that of this particular thing. So 11.2, it will be 22.4. Okay, 22.4 gram is the molecular weight of the gas we are talking about. Okay, so first of all, find the number of moles. Given mass is 2.4 gram, and molar mass we found out from 22.4. This is the number of moles. Each number of moles contains how much liter of volume? At STP, 22.4 liter. Now you can see how beautifully this question is getting cancelled out, and 2.4 is the liter is the right answer. So question number 4, 12th option number 4 is the right answer. Priya Jyoti, are you able to understand 12th option number 4? You're the okay. Priya Jyoti is the first one to answer this question. Nandini, are you able to understand this question? Just a second, let me reset and tell you the problem. A person adds this much gram of sugar in order to sweeten his tea. The number of carbon atoms added are. It's very simple. Priya Jyoti, you try to do this problem. 13th person adds this much gram of sugar, C12H22O11. So first of all, you need to calculate the mass. Okay. C12H22O11 in order to sweeten the number of carbon atoms added are. So it's all talking about, so we first found out the number of moles from this thing and then multiply by 12 and then Na. That will be the answer. That's it. SS sir, I think it means you are saying yes. I am assuming that SS means yes. Okay. Okay, Nandini, try to do this problem. Question number 13. Okay. Attempt this problem. I need to drink some water. Okay, I'll drink water after this question. See, molar mass of the sugar is already given 342. Okay, now you can see how beautiful the numbers are given, 171, 342. So if you halve 342, you get 171 and divide by 100. Got it? So what is the number of moles of sugar? Sir, given mass upon molar mass. So 1.71 divided by 342. So you first cancel out with half, and there is 100 also. So 0.5 into 10 to the power minus 2. So you can say 5 into 10 to the power minus 3. Okay, 5 millimoles are there. The number of carbon atoms added are. So this is the number of moles, okay, of this sugar. Then what is the number of moles of carbon atom? Just multiply by the amount of carbon atom in one. In one sugar molecule, this much number of moles are there. In one sugar molecule, there are 12 carbon atoms. So in this one, 12 into 5. Got it? This much number of carbon atoms will be there. 12, 5, 66 into 10 to the power minus 2. So this is the value of the moles of carbon present in it. So you have to multiply with Na to find number of particles. Okay, let's write the number directly. Na is equal to 6.02 into 10 to the power 23. 23 minus 2 is how much? 10 to the power 21. And 36, you can write it as 36 into 10 to the power 21, or you can write it as 3.6 into 10 to the power 22. 3.6 into 10 to the power 22. This is the right option, option number 1. Got it? 3.6 into 10 to the power 22. Let's see who has answered this question. Nandini Priya has answered this question first, and then Priya Jyoti has answered this question. Both are saying option number 1, and that is the right answer. Okay, got it? Let's start with the next problem, and let me have some water first. Okay. A hydrocarbon contains 80% of the carbon. Then the hydrocarbon is which one? Try to find out the answer, guys. 14th. Okay. There is no water. Let me just have some water. Okay, let's see. Okay, we just need to find which one has the 80% of the carbon, right? So 14 option number 3, somebody has answered 14 option number 3. Okay. Where's my pen? Yeah. Where did I leave it? Oh, here it is. Huh. So CH4, what is the total mass? We just need to see if the ratio is around 0.8 or not, or 0.8 ratio is somewhere around 8 by 10, or you can say 4 by 5. This should be the ratio. What is the mass of carbon? So 12. What is the mass of total? 12, 13, 14, 15, 16. This can never be the answer. 12 by 16, the ratio is not 4 by 5. This can't be the answer. Okay. C2H4, the mass of carbon is 24 divided by, what is the mass of 24, 28. Still again, it's not the answer. Okay, it's not near to 0.8. But if we see this option, okay. Okay. So C2H6 has, wait, somebody 14 option number 3, Priya Jyoti 14 option number, let's see. Okay, 12, okay, so 24, and the mass of S6 is how much? 20 plus 6 is 30. Total mass is 30. Mass of carbon is 24. Let's cancel this out. So 6 4 is 24, 6 5 is 30. So the ratio is 4 by 5, which is equal to 0.8. It means nearly 80%. Okay, not nearly, exactly 80%. So option number 3 is the right answer. So Priya Jyoti, you are right. Nandini Priya, there is something wrong with your answer. Try to check it. I think this is not the answer. 12 by 16 it is, right? 12 by, no, 12, 13, 14, 15, 16, 16. So you cancel this out. How much is the value? 6 and obviously 8. This 3. This is 3 by 4. Okay, 3 by 4 is 0.75, 75%. Okay, so this one, third option is the right answer. Got it? Okay, anyways, try your luck in the next question. Okay, make sure to calculate your marks, guys. Make sure to calculate your marks. I want to hear your marks. How much did you score in this test or whatever you call it, quiz? An oxide of metal has 40% by mass of oxygen. A metal M has atomic mass of 24. The empirical formula of the oxide is. Okay, this one I will give you little bit more time. Okay. I think you 15 seconds is okay. An oxide of metal M has 40% by mass of oxygen. Okay, right? Metal M has atomic mass of 24. Good. The empirical formula of the oxide is. So it is asking us the empirical formula. Let's see if you guys can solve this question or not. Try to find out problem 15 number problem. Option number 1, 2, 3, 4. Which one is the right option? Okay guys, 17. Option number 13, 13 on 10 seconds, 9, 8, 7, 6, 5, 4, 3, 2 and 1, done. Okay, let's start with it. There is an oxide of metal which is 40% by mass of the oxygen. Okay, an oxide of metal M has 40% by mass of oxygen. Okay, so mark. It means if you have that metal oxide, okay, that metal oxide metal oxide you have, okay, in that metal oxide there is a metal and there is oxygen, and by the mass, okay, by the value of mass, if we calculate mass percentage, oxygen is 40%. Okay, got it? And obviously this metal will be 60%, rest of it, right? 40%, this will be 60%. And it is saying us that the metal M has atomic mass of 24. So metal M is having an atomic mass of how much? This is 24. Got it? So 24 is constituting 60%. Then how much this oxygen should constitute? Okay, let's see. The empirical formula of the oxide is, empirical formula it is asking, it means just the ratio, okay, not the exact number, okay, because this formula, this particular information can give you ratio but not the exact number of atoms in that molecule. So it means 60% is 24. Suppose if 60% is 24, it means 1% of the mass is how much? 24 by 60, right? And it means 40% of the mass is how much? Sir, 40% of the mass is 24 by 60 into 40, which is nearly equal to, sir, 2 by 3. 3 is at 24, okay, 8 is 16. So I am getting 16. For 40% of the mass, if 60% is 24 gram, then 40% should be 16 gram, right? And what is the mass of one oxygen atom? Sir, it's 16 gram. It means the oxygen atom present is 1 for one metal atom. Only one oxygen is present, right? We calculated the composition for 60%, 24 is the mass. Then according to it, for 40%, 16 should be the mass. And then according to this, if 24 is just one molecule, then 16, it means it is one molecule. Okay, got it? So M and O, that's it. So option number 3 is the right option. Let's see who has answered this problem. So Nandini Priya, you are the first one to answer this problem. Very good. And Priya Jyoti, you are the second one to answer this problem. Again, very good. Okay. Now let's go on to the next problem, guys. Okay, let me read the problem. A compound contains this much of carbon, this much of hydrogen, this much of nitrogen. The formula of the compound would be. It's very simple, guys. Although it's lengthy, The problem is very simple, but it's lengthy. Okay, so I'll say some questions are going to take more time, some questions are going to take lesser time. They're not going to take equal time. Okay, so once you save some time in one question, you have to give it on to another question. Got it? These are easy, but obviously hard, like lengthy. That's why I'm giving a little bit more time for this question. 15, option number 3. Okay, you have written answer. Now let's see you guys are able to answer for 16 or not. Tell me the answer for the 16. %8.8% carbon, 16% hydrogen, 45.2% nitrogen. Okay guys, let's see. Oh, 45.2. Try to answer for the 16 question, guys. I know it's little bit lengthy, but that's why I've given 30 seconds more time. 20 seconds is left only. 14, 13, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Done. Okay. Now 16th, option number 1. Nandini Priya, you are right. Okay, Priya Jyoti have answered first, 16, option number 1, and second is Nandini Priya. Okay, the problem is very easy. I'll tell you how to do it. 38.8, 16 and 45.2. 38.8, 16 and 45.2. .8, 16 and 45.2. So see, first of all, I have already made a video over this, how to actually calculate the relative number of atoms by using these numbers, okay, percentage numbers, okay. So first of all, you assume this percentage number as amount of grams in mass, got it? So this is, you assume as mass, gram, 38.8 gram, 16 gram, 45.2 gram, got it? Now you have to find the number of moles. 38.8 divided by, how do you find the number of moles of carbon? You just have to divide with the value 38.8 divided by 12. It is 3.23. Got it? Again, now hydrogen is 16. So 16 divided by, what is the mass of hydrogen? 1. So 16 divided by 1 is how much? 16. Got it? Again, 45.2 is the given mass. The molar mass of N is 14. So 45.2 divided by 14. I can use calculator, you guys can't, okay, remember this, 3.22. And see, you have to divide with the smallest ratio. This is the smallest ratio, right? 3.22. If you divide 3.22 with 3.22, what do you get? 1. If you divide 3.23 with 3.22, again you will get nearly 1, okay. 16 divided by 3.22, what is the value 16 divided by 3.22? It is somewhere nearly 4.96, which is nearly 5. So 1 atom of carbon, 5 atom of hydrogen and 1 atom of nitrogen. Carbon 1, nitrogen 1 and hydrogen 5. This is the method, okay. I have uploaded a video regarding this, you can find it in the playlist, okay. The composition problems. So let's see, there should be 5 hydrogen atoms, okay. 3 hydrogen and 2 hydrogen, 5 hydrogen, 1 nitrogen, 1 carbon. So this is the right option, got it. So option number 1 is the right option. Let me just tick it. Okay, got it? This is how you do this problem, got it? Let's see. Okay, Priya Jyoti has already answered this problem and Nandini also. Priya Jyoti is first, Nandini second. Okay. 2.2 gram of a compound of phosphorus and sulfur has 1.24 gram of phosphorus in it. Okay, its empirical formula is, so we have to know the mass of phosphorus and the mass of, what do you call it, the sulfur. just for your information, let me tell you the mass of phosphor is nearly 31, okay, and mass of sulfur is I think around 32. Okay, 31 and 32. So 2.2 gram of a compound of phosphorus and sulfur has 1.24 gram of phosphorus in it. Okay, let's see how can we solve this problem. 24 gram of phosphorus in it, its empirical formula is, so it is asking us the empirical formula. Okay, very easy. It's easy but little bit, just lengthy type problem. It's just lengthy, okay. So 2.2 gram of a compound of phosphorus and sulfur has 1.24 gram of phosphorus in it. So this is the mass of the compound, this is the mass of phosphorus, okay. So it means we can get the percentage of phosphorus in it, yes or no, okay. So the percentage of phosphorus is how much? 1.24 divided by 2.2. So 1.24 divided by 1.24 divided by 2.2, that is 0.56. 0.56, okay. This is the ratio, this is the percentage of the phosphorus in that compound, and we know the mass of phosphorus is how much? 31. Mass of sulfur is how much? 32. Got it? This percentage is nearly 56%, right? It means the number of them should be equal. Let's see which one of them has equal thing. Okay. Okay, P4, S3, P3, S2, P2, S3. We have to calculate this. This is going to be little lengthy. Okay. But anyways, let's do this. P2, S3. Look, this is P3, this is S2. This is P2 and this is S3. If we take it, we want the ratio to be near to 50, right? If we take these compounds, this is 2 into what? 31 plus 3 into what? 32 divided by 2 into 31. Got it? This number is not going to be near to the 50. Same way, P3ST is not going to be near to 56 or something, or 46, 56. Okay? These options are somewhat not looking good. Got it? Understandable? If you understand this, see the value of P and S is nearly around 50%. If you take one as twice, the other is thirds. Okay? The difference in their percentage combination will not be near to the 50, not be half. Okay? So that's why I'm not taking or checking these options. Okay? Good thing is that one of them can be the answer. Okay? But which one of them should I check? Yeah, I have to be very specific, like which one of them should I check? See, phosphorus has lesser mass, right? If the atoms are equal, the phosphorus should have lesser composition. But you can see in this particular problem, the phosphorus has more than 50% of the composition, even though having a lesser mass, right? It has more than 50% of the composition, even though lesser mass. What it means? It means the phosphorus should be in higher number, more number of particles than the sulfur. So this can be an answer, but I need to check it out. Okay. See, this was kind of an active problem. If you want, you can just check it from the percentages. Very easily you will get it, right? But obviously, if you try to check it, it will take a lot of time. I am telling you the shortcuts. Got it? Okay. Now, maybe if you are not able to understand, just put it in the comment section. Okay, 1.24, 2.2 into minus 1.24 is okay. Okay. So you can actually find out the ratio of phosphorus and sulfur. So 1.24 is the mass of phosphorus. Then you can find the amount which is left from this 2.2, which has been told by some person, Priya Jyoti, okay, which is 0.96. So 96 and 1.24. You can actually track the ratio and find the answer. Somebody has answers 17, option number 4. That's what I am saying. Okay, let's try to check it out. So 4 the mass of 31 plus 4 into the mass of 31 plus 3 into the mass of 32. Now this has a chances of being 56. Let me just check if it is 56 or not. And very good, Priya Jyoti, for the suggestion. Okay, so 4 into 31 is how much? 124. Okay, 124, which is like near to this number. You can see 124. It's a very good number. See, that's why they are giving you such good numbers, so that you don't need to calculate it. Plus 3 into 32. Right? So it's 220. I am getting 124 by 220. 124 and 220. Can you see the magic in the numbers? They're not asking you to calculate everything. Okay, so 124 by 220, this is going to be 56% exactly. Okay, and this is the option. Okay, remember this particular problem you could have solved smartly by actually taking the ratios which Priya Jyoti did. Okay, otherwise you can just notice the ratios. Okay, if 124 is divisible by 31 or 32, you can notice this way. Got it? Now let's go on to the next problem, the question number 18. Don't worry, we have not much time left, only 25 problems are there. Don't worry about this. Let's start doing this problem. Okay, I'm going to set the timer for this extra 10 seconds for you guys and start. The number of atoms of chromium and oxygen are this and this respectively. Its numerical formula is, okay, we don't need to know what is the mass of chromium, what is the mass of oxygen. These are the number of atoms. Find the ratio of the atoms, that is the empirical formula. Got it? Ratio of atoms, empirical formula. 4.8 and 9.6, it's nearly, I think, second option or something, I don't know. It's very clear, like I should have given you this 20 seconds extra for this question. But somebody who goes for, like, you know, trying to find. Okay, start doing it, guys. Okay, 20, 17, 16, 15, 14, 13, 12, 11, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, done. Too much easy problem. It is 10 to the power 10, it is also 10 to the power 10. So forget about the zeros, okay? This is 4.8, this is 9.6. The amount of chromium, okay, the number of atoms of chromium, you multiply by 2 to get the number of atoms of oxygen. The amount of chromium, you multiply by the number of atoms of chromium is 1, multiply by 2 to get the amount of oxygen. That's why option number 2 is the right answer. Got it? So let's see, Priya Jyoti is the first one to answer option number 18, option number 2. And then Nandini Priya has answered 18, option number 2, and that is the right option. Okay, got it? This question was way too easy. And now let's go on. Question number 19 for the day, guys. Okay. Let me just see what type of problem it is. A giant molecule contains this much percentage of a metal whose atomic base is 59. Okay. Its molecule contains one atom of that metal. Its minimum molecular weight is, it's very easy. Just 10 seconds extra, 6 seconds is extra. Okay. Chromium, okay, and oxygen. Very good, very good. A giant molecule is there, 0.25%. Giant molecules, okay. Its molecule contains one atom of that metal, okay. Its minimum molecular weight is. Try to find out the answer, guys. Okay, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1, and 0. Let's see what is the right option. Okay, and let's start. Okay, try to visualize this question. It's a very big molecule, okay, and in that big molecule there is a metal of atom. Got it? In that very big molecule there is a metal of atom, and that metal is 0.25%. It means 1/4 of a percentage. Okay, and it's a one atom of that metal. Okay, and atomic weight is 59. It means this 1/4 of the percentage is actually 59 units, right? The weight of that 1/4 percentage is 59 units. What is the weight of whole atom? Very simple, right? Sir, weight of 0.25% is Sir, how much? Sir, it is 59. Okay, so you can say, sir, 0.25 is 1 by 4. So 1% of is equal to 59 into 4. Okay, 100% of the whole weight is how much? 59 into 4 into 100. Okay, so you just multiply 59 into 4. What is the value of 59 into 4? Somebody is saying 19 option number 2, 19 option number 2. Let's see 59 into 4. 59 into 4 is 23600. Okay, 23600. 19 option number 2, 19 option number 2. This is the right option. Got it? 0.25% is 59. 1% is 59 into 4. Then 100% is this. So this is the problem. Got it? So this is the solution. Understandable? This was like easy problem. Okay, it looked hard, but it's easy. So guys, this is the question number 20. 9 gram of aluminum will react. Okay, so let's start this question, guys. 9 gram of aluminum will react with, okay, so 2 aluminum plus 3 by 2 oxygen, Al2O3. Okay, this is a stoichiometric question. You need to compare the stoichiometric ratio. So first convert the 9, okay, I'll not tell you the answer first. Try to do it. 38, 37. Try to attempt it, guys. (17, 16, 15). Quick, guys, quick. Okay, guys, let's start. Okay, so 9 gram of aluminum reacts with how much of the oxygen? Okay, so first of all, what is the mass of aluminum? Mass of aluminum. See, 9 gram is the option that is the amount of mass given to us, right? Mass of aluminum is around 27. Okay, it's lesser than 27 little bit, but it's around 27. Okay. So see, 2 moles of aluminum reacts with 3 by 2 moles of oxygen. Got it? 2 moles of aluminum reacts with 1.4. Okay. So 2 moles react with 1.5 moles. Okay. So what is the amount of moles here? Given mass upon molar mass. It means 1 by 3rd mole of aluminum. Okay. So 2 moles react with 1.5. So 1 mole will react with 1.5 divided by 2. Okay. So 1 by 3rd mole will react with 1.5 divided by 2 divided by 3. This much number of moles. So 1.5 divided by 2 divided by 3. If I cancel 5, it's 0.5. 0.5 by 2 is how much? 0.25. So 0.25 is how much? 1 by 4 moles of oxygen. And what is the value of 1 by 4 moles of oxygen? The mass of one oxygen molecule is 32. Okay. So how much? 4 8 is 32. 8 gram of oxygen, guys. 8 gram of oxygen. 20 option number 2. Let's see who has answered this thing. Okay. Priya Jyoti is the first one to answer this problem. Nandini, you are the second. Okay, and Priya Jyoti is also providing the solution for us. Very good. Thank you. Okay. It's very simple. Convert into moles, convert into oxygen moles, convert into oxygen mass. Simple. 4 steps. Let's go on to the next. Okay, we have just last 5 problems, guys. Bear with us, and I think you will be able to solve this problem. Okay. Okay. The equation, this is the equation. Okay. This is going to be a little bit bigger problem, so you note it down. Note down the equation. 2 aluminum reacts with 1.5 moles of oxygen to give 1 molecule of aluminum oxide. Write down this equation. Write down this problem. And now the options are, first of all, 21, question number 21, okay, let's see. It says that 2 moles of aluminum reacts with 3 by 2 moles of oxygen. Very good, this is right, okay. To produce 7 by 2 moles of aluminum? No, it is just 1 mole of aluminum, right? So this option is wrong. Okay, I'll do this problem, don't worry, you can get your 4 marks easily because it's not fitting in the frame. Again, 2 gram of aluminum reacts with 3.2 gram of oxygen. Very good. To produce 1 mole of Al2O3. Wait. this is grams. Okay, this is grams. Got it? Okay, read this question out. I will show you the problem. Read the option number 2. See, this is grams, this is not moles. Okay, so this option is wrong. Again, this is gram. Again, 3/2 liter and mole. It has compared gram, liter and mole. It's more wrong. Okay, now let's see. In the fourth problem, it is mole, mole and mole. Very good. 2 moles of aluminum. Very good. 2 moles of aluminum. Right. 3/2 moles of oxygen. Very good. 1 mole of Al2O3. Is that the right option? 2 moles of aluminum, 3/2 moles of oxygen and 1 mole of aluminum oxide. So 21, option number 4 is the right answer. Okay, pardon me that I did this problem, but don't worry. Okay, it was like way too late, that's why I did it. Okay, you guys do this problem. Okay, if you are not able to do the problem, do this one. So the question is, 1 liter of carbon dioxide is passed over hot coke. When the volume of a reaction mixture becomes 1.4 liter, the composition of the mixture is how much? Okay, the volume of the reaction mixture. So there's a reaction mixture, it becomes how much? 1.4 liter. It means it expands. What is coke? Coke is carbon. Okay, it means carbon dioxide. 1 liter of carbon dioxide is reacting with carbon to obviously form carbon monoxide, right? Okay, the composition of the reaction mixture is, just I'll give you 20 seconds extra for this problem. 20 seconds extra for the problem. Okay, try to do the problem, guys. 1 liter of carbon dioxide, 1 liter of CO2. You have to pass it over hot coke. Hot coke is carbon, okay, and the volume becomes 1.4 liter. The composition of the reaction mixture is, try to attempt this, guys. Only 30 seconds left. Twenty seconds, guys. Okay, let's try to do this problem. Let's see if somebody has answered the problem or not. Okay, okay. I think it's option 3, sir. 22nd, option number 3. Nandini, 22, again option number 3. Okay, you guys are answering option number 3. Let's see if option number 3 is the right option or not. Okay, so 1 liter of carbon dioxide. So, mark. The equation is carbon dioxide is passed over coke. Coke, I told you, it's carbon. Okay, it's in solid form. It's forming how much? It is forming 2 types of carbon monoxide, 2 molecules. Na? Oxygen 2, carbon 2. Got it? That is the reaction. It is forming carbon monoxide. So it's a like reactive gas, and also it's very poisonous gas. Okay. So now 1 liter of CO2 is passed. Okay. So 1 liter of the CO2 you are passing it. Got it? Over the hot coke, when the volume of the reaction mixture becomes 1.4 liter. So now see, it was X liter, right? Suppose X liter of carbon dioxide has reacted, and in that X liter, this is solid, so it doesn't have any volume. You don't have to take the volume of this thing. It means if X reacts, 2X will be formed. Okay. Now think about this. If I write, okay, reaction mixture becomes 1.4 liter. It means the composition of the reaction was, wait, am I doing something wrong? 0.8 liters of carbon monoxide, sorry, carbon dioxide. It means, wait, see, if we have one, wait, we have one of the carbon monoxide, and if some carbon monoxide, suppose it reacts, right, 1 minus X, so this 2X moles will be formed. Got it? Okay, and the mole is directly related to the 1.4 liter. Okay, now this 1 minus x, 1 liter minus x and 2x. Why am I writing? You can just divide this number with 22.4 to make it in terms of moles, to make it in terms of particles. So that's why I'm directly going with stoichiometry. And in my previous one shot, I have told you that this volume and this number of moles, you can use it in stoichiometry, but not amount of mass, not grams. Okay. So 1 minus x and 2x, if you add them, that will be the total amount of what? Total amount of what? The volume of the mixture, that is 1.4 liter. Got it? Now 1 minus x plus 2x is 1 plus x is equal to 0.4 liter. So x is equal to 0.4 liter. Okay. So x, the value of x is 0.4 liter. It means carbon dioxide is how much? 0.4 is 0.6. Carbon monoxide is how much? Okay, 2x it means 0.8 liter. So you guys have answered option number 22, option number 3. Let's check. 0.6 liter of carbon monoxide. Yes, you are right. And 0.8 liter of carbon monoxide. Yes, you are right. So option number 3 is the right option. And Nandini Priya is the first one. Okay, no, Priya Jyoti is the first one, and then Nandini Priya is the second person to answer this question. Okay. Got it. And also Priya Jyoti is providing the solutions also. Very good. Thank you for your solution. Okay. Again 23 option. Again 23 option number. Let's see. The number of liters of air required to burn 8 liters of this thing is approximately how much? Do it, guys. I have told you first balance the number of carbons, only then balance anything else. The number of liters of air required to burn 8 liters of C2H2. I think it's ethene, right? C2H2 ethene. Let's see who is able to answer this question or not. Okay, 23. The number of liters of air required to burn 8 liters of ethene is approximately how much? 15. Okay, done, guys. The number of liters of air required to burn 8 liters of ethene. First of all, find 1 liter for burning 1 liter, how much it is required. Then we can find for 8 liters. Okay. So C2H2 burns in presence of oxygen to give out carbon dioxide and water. Okay. First of all, balance the carbon, number of carbon C2, C1 multiply by 2. Then balance the number of hydrogen, 2 hydrogen, that is balanced. Okay. Now balance the number of oxygen, 2 to the 4 and 5. So 5 atoms of oxygen is there, and here it is only 2. So make it 5, multiply by 5 by 2. Got it? That's what I do. Now for 1 mole, it is asking how much? The number of liters of air required to burn 8 liters of. Okay, it is asking the number of liters of air. It means oxygen, right? So 1 liter requires 5.2. It means 1 liter requires 2.5 liters of the air. Then 8 liters will require how much? 8 into 2.5. 20 is 20. Okay, we don't have any 20 answer right now over here. The number of liters of air required to burn. Am I doing something wrong? Something's wrong. Just something's wrong. See, C2. Am I doing something wrong? Can you guys point out? 23 option number 4. 23 option number 4. You are writing 23 option number 4. The number of liters of air required to burn 8 liters of C2H2 is approximately how much? I have to burn 8 liters of C2H2. Okay. 8 into 2.5. Oh, I am getting some other answer. Can you guys point out any problem in this scenario that what I am doing right now? The number of liters of air required to burn 8 liters. Am I confused? C2H2 is approximately how much? Am I doing something wrong? Can you guys point out quickly? Wait, let me check. we have to burn ethene, right? And to burn ethene, how much is the air required? Ethene, wait. Our equation is right. Okay, good. 2 carbon dioxide, 1 hydrogen. Eight into 5/2. Oh, one thing is wrong with us. What we did wrong is, see, we know that for 1 liter we require how much? 2.5. So for 8 liter we require how much? 5/2 into 8. Okay. 20 liters of oxygen, right? Not air. That is the problem. Air contains nearly 20% of what? Oxygen. Okay. So if we want 20 liters of oxygen, we have to utilize 100 liters of air. Okay. That is the problem. Okay. I thought air is actually taken as what do you call it? Okay. 20 liter of O2 divided by the volume of the oxygen in air. Thank you Nandini Priya and thank you Priya Jyoti for telling me the answer. Okay. That's how you do it. Okay. So air is 100 liter. In that 20 liter will be the what? Oxygen, and that will be able to burn 8 liters of ethene. Now 23 done. Let's go on to 24. I'll not show the problems for the next lecture. Okay. I'll give you extra little bit time for this question. Okay. 0.5 mole of BaCl2 is mixed with 0.2 mole of Na3PO4. The maximum number of moles of Ba3PO4 that can be found from is, it is asking number of moles. Okay, 0.5 this, 0.52. You have to find the limiting reagent. How do you find limiting reagent? This mole divided by the coefficient 2 or 3, whichever is lesser is the limiting reagent, and you have to do the equation according to that thing. Okay. Okay guys, try to do it. This is the second last problem. Second last problem guys. I think our display is little rotated. We need to get it fixed. Okay, just 40 seconds left. Okay, you have to find which one is the limiting reagent. Okay, so you have to divide it with the coefficient, then find the answer according to it. .2 mole of Na3PO4 Okay, 10 seconds. 9, 8, 7. Post your answer guys. 6, 5, 4, 3, 2, 1. Okay. Done guys. See, we first need to find the limiting reagent. Once we know that this compound is the limiting reagent, which is not letting the reaction go fully, okay, then according to that compound we are going to do the calculations. Okay, so see, how do you find the limiting reagent? The process is to first, this is the number of moles of BaCl2, right? Okay, and Na3PO4, right? What is the number of moles? 0.2. You have, what is the stoichiometric coefficient? For BaCl2 it is 3, so divided by 3. For Na3PO4 it is 2, so divided by 2. What answer you are getting? It is nearly, if you take, it's like 0.166, right? And this is nearly what? This is 0.1. So which one is lesser? Na3PO4 is lesser. Hence we have to do the calculation according to this. Okay. Somebody has answered. I'll see it. Okay. This is the limiting reagent because its given moles divided by the limiting reagent has a lesser value. Got it? So we have to calculate it according to it. So 0.1 mole of Na3PO4. 0.1 mole of Na3PO4. Sorry, 0.2 moles is given. 0.1 is just the limiting reagent coefficient. Okay. So 0.2 mole of Na3PO4 will produce how much of Ba3PO4? So this is 2 mole, it will produce 1 mole. It means if it is 0.2 mole, it will produce 1 mole. Oh, sorry, 0.1 mole. Got it? So fourth option is the right answer for this question. So Priya Jyoti is the first one to answer this problem, okay, and Nandini is the second one to answer this problem. Very good, Priya Jyoti, you are doing good, okay. Nandini, you are also doing good, okay. If 8 milliliter of uncombined oxygen remain after exploding oxygen with 4 milliliter of hydrogen, okay, the number of milliliter of oxygen originally were, okay, again same type of problem, just a little bit tricky. Let me have some water, guys. Twenty seconds, guys. Last problem of the day, okay. And after that, just quickly calculate your marks and let me know down in that live chat section and tell me how much marks you got, or you can tell me how much questions you got correct or wrong, okay. I think we're done. 2, 1, 0, done. Okay. So 25, let's see. Now guys, the thing is 8 milliliter of uncombined oxygen was remaining after exploding oxygen with 4 milliliter of hydrogen, okay. So it means hydrogen is reacting with oxygen to form water. How much oxygen? So I will just do it half, okay. So ratio is 1, half 1, okay. So it said that 8 milliliter of uncombined oxygen was left, okay. So 8 milliliter was left, rest got reacted with 4 milliliter of hydrogen, okay. So 4 milliliter of hydrogen can react with 2 milliliter of oxygen, right? Yes or no? Because rest of it reacted with 4 milliliter of hydrogen, it means 2 milliliter of oxygen must have been present and 8 milliliter was already left. Total amount of oxygen is 10 milliliter, okay. So the number of milliliter of oxygen originally was how much? Obviously it will be 10, right? Because if this is 10, then this 2 will react with 4 milliliter as given in the question, okay, and rest 8 will be left as given in the question. Got it? Hence total amount of milliliter of oxygen is 10 moles. I hope you guys got this answer, right? This was the last problem, and let's see who has answered this problem. Where's my mobile? Okay guys, let's see. Let me change this thing, okay. We are done with the session, okay. Now let's see who has answered this question. So 25 option number 3 Priya Jyoti, 25 option number 3, very good Nandini. Okay, and just calculate your marks quickly. Guys, calculate your marks and tell me. How much questions you did right and how many questions you did wrong? Tell me. After that, I will end the session, okay. And somebody who is watching this recording, okay, you can actually go in the comment section and tell me how much you have done. I try to go with the comment section. And if you don't know some concepts, some basic concepts of chemistry, you can actually just watch one shot which I took in yesterday. You will find this on our channel, okay. One shot, some basic concepts of chemistry. This is the, okay. Nandini, Priya, you did 21 right out of 25, very good. What about you, Priya Jyoti? Okay, not getting any answer from Priya Jyoti. I think she is out of the live session. Okay. Okay, 22 question correct and 3 question wrong. So 21 correct and 4 wrong. Okay. Priya Jyoti got 22 right, okay, and 3 question wrong, whereas Nandini got 21 correct and 4 wrong. Okay, anyways, that is it for the day, guys. Take care, see ya, bye bye, have a nice day, okay. And in the next session, we'll come back with rest of the 25 questions, okay. Make sure you be ready with those questions and also try to improve your accuracy. Got it? Till then, bye bye, see ya, have a nice day. Take care, guys.